The bridge of a modern commercial vessel is dense with advanced technology, featuring sensors and integrated systems engineered to make the vessel virtually uncrashable. Yet, despite these digital safeguards, research indicates that around 60 a constant barrage of unprioritized system alerts creates high stress and decision paralysis, as officers struggle to distinguish critical warnings from background noise. With reduced manning, isolated bridge officers are often forced to multitask, attempting to navigate the ship while triaging a flood of irrelevant data. A human operator starved of cognitive bandwidth becomes increasingly susceptible to error, particularly during the critical, time-sensitive maneuvers that define life at sea. In August 1999, the cruise ship Norwegian Dream and the container vessel Ever Decent collided in the English Channel, despite clear, sunny weather and good visibility. The bridge was operating in heavy traffic congestion, with an officer on watch attempting to monitor two different ARPA radar systems simultaneously. During this complex navigational window, a crew member entered the bridge to ask the officer to sign a garbage record book, pulling his attention away from the instruments. Just minutes before impact, the Ever Decent called via VHF radio to request a course alteration, further splitting his attention. The intersection of mundane administrative tasks and overlapping communications hijacked the officer's focus exactly when maximum situational awareness was required. This radar plot from 0048 shows the dense cluster of ships. Returning to the screens, he failed to properly interpret the data. The officer mistook the true vector of the Ever Decent for its relative vector, falsely believing it would pass safely ahead. He realized the error too late. Despite throwing the engines full astern, the ships collided. The official investigation reached a startling conclusion. The abundance of technology, specifically the act of running two radars and a VHF radio simultaneously, actually caused the officer's confusion. Relying on raw data output without an intuitive human-machine interface actively facilitates accidents rather than preventing them. These systemic failures forced the maritime industry to shift its focus toward radically redesigning the human-machine interface. The industry introduced the Bridge Alert Management Protocol, or BAM, to create a quiet bridge and prevent alarm saturation. This system prioritizes alerts into defined categories: emergency, alarm, warning, and caution. Standardized symbols, like this red X over a triangle, ensure officers instantly recognize the urgency of a situation. Modern e-navigation also utilizes S-mode, a standardized default presentation that allows seafarers to move between different ships without constantly relearning equipment interfaces. By categorizing alerts and standardizing displays, the industry is turning chaotic data into clear, actionable guidance. The solution to the crushing administrative burden is the digital maritime single-window platform. This platform centralizes data exchange, eliminating the need for masters to manually copy and paste spreadsheets or manage hard copies for every individual port. Maritime safety relies on the ruthless curation of information to ensure that the bridge team receives only what is necessary for the task at hand. By engineering systems that respect the processing limits of the human brain, we empower seafarers to make the critical, life-saving decisions that technology cannot make for them. A moment of calm. When the data is managed, the horizon is clear.